When people first hear the term BIM, they often think about software, 3D models, or digital drawings. But BIM is much more than that. BIM is really a project management process. Its value comes from helping project teams organize information, coordinate decisions, and identify problems before construction begins. Successful BIM depends on several elements working together. Technology is important, but technology alone is not enough. People, process, strategy, collaboration, and efficiency all have to support the same project goals. One important point here is that BIM should not be treated as just a 3D modeling tool. It should be used as an information management and decision-making tool. Also, the model does not always need to include every possible detail. The key is to model the right information for the right purpose at the right time. So, throughout this chapter, the main message is simple. BIM becomes valuable when the entire project team uses a shared digital model to support better decisions. In the past, many teams focused mainly on the model itself. They might ask, how complete does the model look? Or, how detailed is the model? But successful BIM requires a different question. What is this model supposed to help us do? That shift is very important. A BIM model should be developed around its intended use. For example, if the purpose is 3D coordination, the model needs enough information to detect conflicts between building systems. If the purpose is 4D planning, the model needs to connect to schedule information. If the purpose is 5D cost estimating, the model needs to support quantity and cost-related data. These specific applications are called BIM uses. Common BIM uses include 3D coordination, 4D planning, 5D cost estimation, and facility management. The important point is that BIM uses should be identified early and documented in the BIM execution plan, or BEP. This helps the team avoid unnecessary modeling and make sure that the information being created actually supports project decisions. So, purpose-driven BIM is not about making the most impressive model, it is about making a useful model. A common misunderstanding is that more detail always means a better model, but that is not always true. A model can be very detailed and still not be useful. What matters is whether the information in the model is reliable and appropriate for the task it is meant to support. This is where the concept of level of development, or LOD, becomes important. LOD should not be understood simply as visual completeness. It is not about modeling every small part of a building element. Instead, LOD communicates how reliable the model information is for a specific BIM use. For example, if a window is being modeled for general coordination, the team may only need its correct size, location, and basic performance information. The model may not need every fastener, seal, or small hardware component. A fit-for-use model contains essential data and stays lean. An over-detailed model can create extra data, heavy files, and information that quickly becomes outdated. This is especially important for facility owners. Owners need accurate and maintainable information, not unnecessary attributes that become difficult to update over time. So, the goal is to include information that supports design, construction, and operation, and nothing more than what is needed. Overmodeling occurs when the team creates more model information than the project actually needs. This usually happens when BIM uses are not clearly defined. In other words, if the team does not know what the model is supposed to support, people may keep adding detail just because they think more information is better. But more detail does not always create more value. First, overmodeling wastes time and labor. Modelers may spend many hours creating components or attributes that do not support any real project decision. This can be especially harmful during early design, when the project still needs flexibility. Second, overmodeling creates heavy files. Large federated models can be slow to open, difficult to navigate, and more likely to cause software performance problems. Third, overmodeling can reduce collaboration. If the model is too slow or difficult to use, people may start avoiding it. Coordination meetings may then focus more on model performance issues than on solving actual construction conflicts. The key principle here is very clear. Unused information has no value. If data does not support a project goal, it only adds weight to the model. Effective BIM management requires the team to decide what information is necessary, what should be simplified, and what should be left out until it is actually needed. Successful BIM implementation requires clear roles. BIM involves many participants, including BIM managers, BIM coordinators, model authors, designers, engineers, contractors, subcontractors, and owners. If responsibilities are not clearly defined, the project team can experience duplicated work, coordination conflicts, and delayed problem resolution. This is why the BIM execution plan, or BEP, is so important. The BEP should serve as the central document for organizing BIM responsibilities. One useful tool inside the BEP is the responsibility matrix. For example, the BIM manager may be responsible for overall BIM coordination and standards. The BIM coordinator may manage discipline model integration and clash reports. The model author may be responsible for creating and updating model elements. Clear responsibilities help the team communicate better and resolve issues faster. The slide also highlights client expectations. Sometimes owners may request broad terms like full BIM or LOD 500, but those terms can be unclear if they are not translated into specific information requirements. That is why owner requirements should be connected to documents such as the EIR and AIR. The EIR explains what information the owner expects the project team to deliver. The AIR identifies the asset information needed for facility operation and maintenance. So, the main point is that BIM expectations must be specific, documented, and connected to actual project needs. At the beginning of the project, the contract required a high level of MEP modeling detail. The assumption was that more model information would automatically lead to a better construction outcome. However, as the project moved forward, problems began to appear. The federated model became very heavy, software performance slowed down, coordination meetings became less productive, and the team spent too much time discussing minor components instead of focusing on major field conflicts. In other words, the model was becoming too detailed for its actual purpose. The BIM manager then reviewed the project's BIM objectives. The team realized that the main BIM uses during construction were spatial coordination and hard clash detection. To support those goals, the model did not need every minor MEP component. It needed reliable information about major systems that could create real conflicts in the field. So, the team revised the BEP. They reduced unnecessary modeling requirements and focused on major ductwork, large diameter piping, and primary structural elements. As a result, file sizes became smaller, model performance improved, coordination meetings became more focused, and the burden on subcontractors was reduced. The lesson from this case is very important. A lean, purpose-driven BIM strategy is often more effective than requiring maximum detail. In BIM, the right information is more valuable than the most information.